So in chapter 7, we're mainly looking at quadrilaterals, but we start off looking at angles in a polygon. So our essential question for this section is, what is the sum of the measures of the interior angles of a polygon? So triangle, you're all familiar with, is 180. Quadrilateral, you should be familiar with as 360. But then we have 5-sided figures, 6-sided figures, 7-sided figures. So what do those add up to? So our first thing is our polygon interior angles theorem, which says the sum of the interior angles of a convex polygon can be found using the formula n-2 times 180. So n is the number of sides. So in a triangle, 3 minus 2 is 1. 1 times 180, I have 180. Quadrilateral, 4 minus 2 is 2. 2 times 180 is 360. So it's going to constantly go up by 180. This is based on the number of non-overlapping triangles that I can draw in a shape. And that's where that formula comes from. The corollary just states the sum of the measures of the interior angles of a quadrilateral is 360, which we can show by plugging 4 in there. So an example of the type of problem you might see here, find the sum of the measures of the interior angles of a convex hexagon. So I look at my shape, I say there's 6 sides, I plug 6 in, 6 minus 2 times 180. So I'm doing 4 times 180, which gets me 720. You should know the names of the polygons. I can do this problem and not give you the picture. We also have example 2, where it's saying the sum of the measures of the interior angles of a convex polygon is 1260. Classify the polygon by the number of sides. So I'm working backwards here, and when I get my n, I need to know what that shape is. So n-2 times 180 equals the 1260. Right? And then we're just solving that problem for n. So the first thing I do is divide by 180. And I get n-2 equals 7. Then I add 7, or add 2 to both sides. I get n equals 9. So then our question is, what is that shape? Which is a nonagon. Okay, and every time we do those problems, it will look fairly similar. The 1267 and 9 will change, the right side. The left side will stay the same when I'm going through those problems. Example 3 is similar. Right, some of the measures of the angles of a convex polygon is 1620. Classify the polygon by the number of sides. So, n-2 times 180. Okay. Sometimes people will distribute the 180 and then solve it. I think that's an extra step. If you're more comfortable doing that, that's fine. But make sure you're then adding and dividing by 180. It's more straightforward to just do what we did above. Divide by 180. I get n-2 equals 9. So n is 11. Okay, and then an 11-sided figure we just named by the number of sides. So that would be an 11gon. Example 4. Find the value of x in the diagram. So there's two things. One, you need to know what these add up to. All right. Most of you for a quadrilateral are going to be comfortable saying, okay, I know that's 360. Just add everything up to 360. If you don't, then use the n minus 2 times 180 formula, which I'll show on the next one where it's not a quadrilateral. So here I'm going to say, all right, we should know this is 360, so I'm just going to add things up. I want to do 136 plus 112 plus 71 plus my x equals 360. And watch what the problem's giving you. Sometimes you may have multiple angles that have x, or an angle that's 2x. So make sure you're taking that into consideration. Add my stuff up here. I get 318 plus x equals 360. Right. Subtract 360 from both sides, or 318 from both sides, and I get that x is 42. I've done my problem. So we're going to flip over the paper here. See a similar problem up top. However, now they're giving me a five-sided figure. Right, and as you're doing these, some of you may remember what this is, or some of you may know it off the top of your head, but I'm going to show plugging in to the formula. All right, so I add everything up. 68 plus 105 plus 109, and then the two that I don't know are equal, so we call those both x. That's equal 5 minus 2 times 180. So I add my numbers, I add my x, and I solve my 5 minus 2 times 180. Get 282 plus 2x equals 540. You do want, if your numbers are separated or together, that you're combining everything that you're supposed to be combining. Subtract the 282, we get 2x equals 258. Divide that by 2, and I get 129 as my x. The next thing we look at is exterior angles. So we have the Polygon exterior angles theorem, which says the sum of the measures of the exterior angle of a convex polygon, one at each vertex, is 360. So they show me a five-sided figure there. The number of angles do not matter. Those angles are going to add up to 360 in every shape. So these 5 angles would add up to 360. In example 4, they give me 4 angles. Those 4 angles also add up to 360. So when I'm looking at example 4, we'd have 85 plus x plus 89 plus 2x equals the sum of my exterior angles, which is 360. And then we're going to solve that. So I combine all my numbers, combine my x's. We get 174 plus 3x equals 360. Subtract the 174. 3x equals 186. Divide by my 3, and I get that x is 62. All right, we then look at 3 terms that we should know: equilateral, equiangular, and regular. So equilateral, all sides are the same. Equiangular, all angles are the same. Regular is both. And again, that's the one that tends to trip people up. Remember, regular does not mean normal. Regular means all the sides and all the angles are equal. So equilateral, all sides congruent. Equiangular, all angles congruent. And regular, equilateral and equiangular. Right, so a regular polygon would be a square, not a rectangle. Okay. Then it says find the measure of an interior and an exterior angle of the indicated regular polygon. Right, so I can only do this because I know they're all equal. Right, so a regular pentagon, we have 5 sides. 5 minus 2 times 180 gives me my interior. To find each angle, I then divide that by the number of sides, which is 5. All right, so 5 minus 2 times 180 gives me 540. Divide that by 5, and we get 108. Exterior, our exterior is always 360, so I just do 360 divided by 5, you get 72. All that changes as I change my shape to a nonagon is that instead of 5 sides, we have 9 sides. So wherever I have a 5 on the previous one, we have a 9. Right? So you have n minus 2 times 180. That will get me my sum. Divide that by 9. So my total is 1,260. Divide that by n. We get 140. Right? And exterior 360 divided by 9. We get 40. No, because our interior angles and exterior angles should always add up to 180 because they should be making a straight line. All right, so I can use that to check myself. I'll also write down the formulas here. If you like thinking it more of a formula, our interior formula would be n minus 2 times 180 over n. And our exterior formula would be 360 divided by n. And that is the formula I would use to get these. Turn the page, we have one more problem that we're looking at, right, which is sort of setting an example of where you might use this. The trampoline is shown is shaped like a regular dodecagon. Find the measure of each interior angle and the measure of each exterior angle. So I probably wouldn't need actually both of these in real life, but if I'm putting it together, I might need to know what that angle is if I'm having an issue. All right, so that would be a place we could use this. So we're just plugging into the 2 formulas we just used. First, dodecagon, 12-sided figure. So for A, we have 12 minus 2 times 180 divided by 12. So when I do that, I multiply that out, divide by 12, we get 150. Then B, right? And again, these add up to 180, so this should be 30. But it gives me a good chance to double check. I do 360 divided by 12, and that does give me 30. Right? And that is how we do each exterior and interior angle in a regular polygon.